Soaring High: The Science and Art of Flight. Introduction. Welcome, aviators and enthusiasts, to our educational program about the marvel of flight. From the delicate flutter of a butterfly's wings to the powerful thrust of a jet engine, flight has fascinated humans for centuries. Today, we'll explore the physics behind flight and how birds, insects, and humans achieve the seemingly impossible feat of defying gravity. Segment 1. The physics of flight. To understand flight, we need to dive into the fundamental principles of physics that make it possible. Lift. The key to flight is lift, which is generated when the air pressure above a wing is lower than the pressure below it. This difference in pressure creates an upward force that counteracts gravity. Bernoulli's principle. Named after the Swiss mathematician Daniel Bernoulli, this principle explains that as the speed of a fluid, in this case, air, increases, its pressure decreases. Air moves faster over the curved upper surface of a wing than the flatter lower surface, creating lift. Newton's third law: for every action, there's an equal and opposite reaction. As wings push air downward, the reaction pushes the wings upward, contributing to lift. Thrust. To achieve flight, an object must overcome drag, air resistance, by generating thrust. This force propels the object forward and can be produced by flapping wings, engines, or other means. Weight and balance. The weight of the flying object must be balanced and managed to achieve stable flight. The center of gravity plays a crucial role in maintaining equilibrium. Segment 2. Birds in flight. Birds are nature's most elegant flyers, mastering the art of flight through millions of years of evolution. Wing shape and feathers. Birds have wings with a specific shape, or airfoil, that creates lift. Their feathers are designed to be lightweight yet strong, and they can adjust them for maneuvering and speed. Flight muscles. Birds have powerful flight muscles, especially the pectoral muscles, which enable them to flap their wings with great force. Wing beats. Different birds use different wing beats. For example, hummingbirds have rapid wing beats, while albatrosses glide with minimal flapping. Control surfaces. Birds use their tail feathers and primary wing feathers to control direction, speed, and stability. Segment 3. Insects in flight. Insects, despite their small size, have perfected unique methods of flying. Wing mechanisms. Insects have wings that operate in a variety of ways. Some, like butterflies, have two pairs of wings that work in unison. Others, like flies, have specialized wing structures that allow rapid and complex maneuvers. Muscle systems. Insects have two types of flight muscles: direct and indirect. Direct muscles attach to the wings, while indirect muscles attach to the thorax, changing its shape to move the wings. Rapid flapping. Many insects can flap their wings at incredibly high speeds, creating enough lift to hover, dart, and perform intricate aerial acrobatics. Segment 4. Human flight. Humans have long dreamed of flight and have achieved it through innovation and technology. Aircraft design. Modern aircraft are designed with wings that provide lift. The shape, size, and angle of the wings are carefully engineered to maximize efficiency. Engines. Aircraft engines produce thrust to propel the plane forward. Jet engines, for example, work by compressing air, mixing it with fuel, and igniting the mixture to produce a powerful exhaust. Control surfaces. Airplanes have various control surfaces, such as ailerons, elevators, and rudders, to manage lift, direction, and stability. Helicopters. Unlike fixed-wing aircraft, helicopters achieve lift through rotating blades that act as wings. The angle of these blades can be adjusted to control direction and altitude. Innovation and exploration. From the Wright brothers' first powered flight to modern space travel, human ingenuity continues to push the boundaries of flight, exploring new frontiers and improving technology. Conclusion. Flight is a testament to the wonders of physics, evolution, and human innovation. By understanding the principles of lift, thrust, and balance, we can appreciate how birds, insects, and humans achieve the incredible feat of flying. As we continue to explore the skies and beyond, the story of flight remains one of the most fascinating chapters in our quest to conquer the heavens. Closing remarks. Thank you for joining us on this journey through the science of flight. Remember, whether it's a bird soaring above, an insect darting through the air, or an airplane cruising at high altitude, the principles of flight connect us all to the skies. Keep exploring and stay curious. Here are some intriguing facts about flight. Lift and drag. Flight is achieved by balancing lift and drag forces. Lift is created by the shape of the wings, which are designed to allow air to move faster over the top than underneath, creating lower pressure above and higher pressure below the wings. Birds and bones. Birds have lightweight, hollow bones that reduce their body weight, making it easier for them to fly. Their wings are also specially adapted with strong muscles and feathers for various types of flight. Insect wings. Insects can achieve rapid and complex flight thanks to their flexible wings and powerful flight muscles. For example, a dragonfly's wings can beat up to 30 times per second. Helicopter mechanics. Unlike airplanes, helicopters have rotating blades that act as wings. By changing the angle of these blades, helicopters can hover, move sideways, and even fly backward. Jet engines. Modern jet engines operate by compressing air, mixing it with fuel, and igniting it. The resulting high-speed exhaust gases provide the thrust needed to propel the aircraft forward. First powered flight. The Wright brothers, Orville and Wilbur, made the first powered, controlled flight on December 17, 1903, in Kitty Hawk, North Carolina. Their plane, the Wright Flyer, flew for 12 seconds over a distance of 120 feet. Supersonic speed, breaking the sound barrier, or flying faster than the speed of sound, Mach 1, was first achieved by Chuck Yeager in 1947, piloting the Bell X-1. Supersonic speeds can cause a sonic boom, a loud sound similar to an explosion. Spaceflight. Rockets achieve flight by expelling gases at high speeds from their engines. This propulsion allows spacecraft to overcome Earth's gravity and travel into space, making exploration of the cosmos possible. Hot air balloons. The first successful human flight was in a hot air balloon in 1783. Hot air balloons work by heating the air inside the balloon, which becomes less dense than the cooler air outside, creating lift. Aerodynamic shapes. The design of aircraft, from commercial planes to gliders, takes into account aerodynamics to minimize drag and maximize lift. The streamlined shapes help in reducing air resistance and improving fuel efficiency. Flight is a remarkable achievement of nature and human engineering, showcasing the wonders of physics and innovation.